Hi guys, it's Sia again, and welcome to another episode of MadSci. In today's episode, we're going to discuss the optical properties of materials. So, let's get started.
Our learning objectives for this video.
Now, let's talk about the basic concepts on optical properties.
Electromagnetic radiation. Electromagnetic spectrum. Electromagnetic radiation, from a quantum mechanical perspective, is composed of groups or packets of energy, which are called photons. The energy of a photon is said to be quantized or can only have a specific values defined by this equation, where h is a universal constant called Planck's constant. Thus, photon energy is proportional to the frequency of the radiation or inversely proportional to the wavelength.
When light proceeds from one medium into another, some of the light radiation may be transmitted, observed, or reflected at the interference between the two media. Optical phenomena that occur in solid materials involve interaction between electromagnetic radiation and atom, ions, or electron. Two of the most important interactions are electronic polarization and electron energy transition.
As you can see in this diagram, an electric field interacts with the electron cloud surrounding each atom within its path to induce electronic polarization. Electron transition happens when the absorption and emission of electromagnetic radiation may involve electron transitions from one energy state to another.
You should remember that all the photon's energy of an electron is observed during excitation state, but it can't remain in an excited state because after a short period of time, it falls back or decays into a ground state or what we call the unexcited state. All frequencies of visible lights are absorbed by metals. This is because of the continuously available empty electron states which permits the electron transition. Metals are opaque to all electromagnetic radiation on the low end of the frequency spectrum, from radio waves to infrared to ultraviolet radiation. However, metals are transparent to high-frequency radiation.
Since metals are opaque and highly reflective, the perceived color is determined by the wavelength distribution of the radiation that is reflected and not absorbed. Aluminum and silver are two metals that exhibit reflective behavior. Copper and gold appear red, orange, and yellow respectively because some of the energy is not re-emitted as visible light.
Now, let's go to the optical properties of nonmetals in terms of their refraction, reflection, absorption, and color.
Refraction. The index of refraction is defined by this equation. In simple words, index of refraction is the ratio of the velocity in a vacuum to the velocity in the medium.
You could say that the larger an atom or ion, the greater will be the electronic polarization and index of refraction, and it will have a slow velocity. Reflectivity vary with wavelength, and it is greater when the index of refraction is high.
Absorption. For example, a diamond having a band gap of 5.6 electron volt is opaque to radiation having wavelength less than about 0.22 micrometer. Color. For example, cadmium sulfide has a band gap of about 2.4 electron volt. Because of the composition of the transmitted beam, it has a yellow-orange color. On the other hand, high purity and single crystal aluminum oxide or sapphire is colorless. Ruby, which has a brilliant red color, is simply sapphire to which has been added 0.5 to 2% of chromium oxide.
Opacity results when the scattering is so extensive that virtually none of the incident beams are transmitted back to the surface. Luminescence is the phenomenon wherein the material can absorb energy and then re-emit its visible light. Luminescence has a number of commercial applications.
Fluorescence light, ultraviolet light, and detection of X-rays and gamma rays. Light amplification by stimulated emission of radiation. This is a schematic representation of the simulated emission and light amplification for a ruby laser.
Semiconducting materials such as gallium arsenide may also be used as layers that are employed in a compact disc player and in the modern telecommunication industry.
This is a diagram showing the layered cross-section of a gallium arsenide. A variety of other substances may be used for lasers. The table that you can see lists the several common lasers and their characteristics.
Signal transmission through metallic wire conductor is electronic, whereas using optically transparent fiber is photonic, meaning it uses photons of electromagnetic radiation. The use of fiber optic system has improved the speed of transmission, information density, and transmission distance with a reduction of error rate.
This is a digital encoding scheme for optical communication. A high power pulse of photons means 1. A low power photon pulse represents a 0. This picture shows the cross-section of an optical fiber, which is said to be the heart of the communication system.
There are two design types of optical fiber.
Step index, optical fiber design.
Pulse broadening is largely avoided by the utilization of the graded index design.
Graded index, optical fiber design.
That's it for today's episode on optical properties of materials. I hope you learned from this video. Don't forget to click the subscribe button down below. And I'll see you guys next time. Bye!